All right, you guys, let's go ahead and get started here on lesson 5.6. This is quadratic word problems in factored form. We will be seeing similar lessons like this about two more occasions where we're talking about vertex form and then standard form. But more or less, it's the same idea with when we come with quadratic word problems. In this case, students can interpret key features of quadratic word problems in factored form. A few of our vocab terms here is at the time of, profit, maximum, minimum, x coordinate of the vertex, and so on. In this case, guys, the goal with these word problems is we want to go ahead and identify whether we're going to be looking for key features in quadratic equations, whether it's going to be a Y-intercept, which in this case indicates the start or starting point. We could either also be looking for the x coordinate of the vertex, the y coordinate, or the x intercept or intercepts. There could be one or two. So in this case, this is what we're going to go ahead and be doing. We want to go ahead and identify what they're asking us to find. So let's go ahead and get started here with example 1. So in example 1, it says a rocket is launched from a platform. Its height in meters x seconds after launch is modeled by our following equation. We have h of x equals -4 times x plus 2 times x minus 18. Whenever we're working with word problems, the first thing we want to go ahead and do, is we want to go ahead and label our variables. Label variables. And this is important because whenever we're reading through the word problems, they are going to be giving us certain units, which in this case are either going to be representing x or y. So first thing we want to go ahead and do is label the variables. Now, in this case, in the word problem, they are giving you two units of measure. One of them is the height in meters, and the other one is x seconds. So we want to go ahead and identify what represents x and what represents y. In this case, guys, they're actually telling us we have x seconds. So whenever they mention anything about seconds, we know that's actually representing the x. And that would actually leave y as the height in meters. Height in meters. All right. Most of the time, they are going to be giving you x seconds or other certain units of measure in this case. But when it comes to identifying whether it's x or y, y is usually the biggest or the largest unit of measure. X is usually the smallest one. There's going to be other occasions where we're going to be probably talking about profit of a company and then the amount of dollars they sell, I don't know, an app. So dollars would be a smaller amount, which would represent x. In this case, the profit will most of the time be in millions, representing y. So in this case, once again, x represents seconds, y represents height. So let's go ahead and get started with our first one here. First question says, what is the height of the rocket at the time of launch? In this case, I will be highlighting because it is giving me a unit of measure. What is the height? They're asking us for the height at the time of launch. In this case, we did identify that height represents y. And in this case, they're saying at the time of launch, it's actually stating at the beginning. So what is the height at the beginning? Once again, any point that in this case represents the start is going to be our y-intercept. So we actually have to find the y-intercept. Now, in this case, guys, we could actually graph this on Desmos, but I will be showing it by hand. In order for us to solve for the y-intercept, I will have to make x equal to 0. Just because when we graph a parabola, any y-intercept, x is always going to be equal to 0. So if you want to solve for your y-intercept or find the value of the y-intercept, x has to be 0. So we're going to go ahead and substitute x equals 0 into the equation. So we have h of 0 equals -4 times 0 plus 2 times 0 minus 18. So let's go ahead and simplify. -4, 0 plus 2 is 2, and 0 minus 18 is -18. So let's go ahead and multiply this out. And let's do that. And I'm going to go ahead and do -4 times a 2 times a -18. Answer in this case is 144. So in this case, h of 0, or our y-intercept, is located at the point 0, 44, or the height of the rocket is 144 meters above the ground. All right, that's our answer for the first one. And once again, that is us identifying our y-intercept. Y-intercept. All right, so if we want to solve for y, once again, you need to substitute x equal to 0 into the equation. All right, let's go ahead and take a look at the next one. Next one says, how many seconds after launch will the rocket hit the ground? Now, let's go ahead and highlight the unit of measure they're giving us. In this case, says how many seconds after launching will the rocket hit the ground? In this case, once again, I am going to be doing another sketch here. I'll do it up here. Once again, if you do have a parabola, we now know, once again, parabola started here and then it went down. This here represents our starting point. Let's do it again. Our starting point. And in this case, it says, how many seconds after launching will the rocket hit the ground? In this case, guys, from our starting point up to when it ends, where do we consider the end? When does the rocket hit the ground? In this case, when the rocket hits the ground, it's actually going to be our x-intercept. And in this case, seconds do represent x. So in this case, they're actually talking about our x-intercept. So here, we have to find the x-intercept. All right, once again, seconds represents x, and the value in this case we're looking for is our x-intercept. So in order for us to actually solve for the x-intercept, we actually have to make y equal to 0. So just how the y-intercept, x had to be 0, if we want to find the x-intercept, y has to be equal to 0. Or in this case, h of x has to be equal to 0. Once again, h of x, g of x, f of x is a fancy way of saying y. So if we want to solve for our x-intercept, we have to make our x's in this case, or the binomials of the original equation, equal to 0. All right. So once again, we have h of x equal to -4 times x plus 2 times x minus 18. So we have to make h of x equal to 0. All right. And in this case, guys, we are solving for the x-intercepts, and factored form equations help you identify the x-intercepts. In order for us to do that, we will have to make both of these two binomials equal to 0. So I have x plus 2 equal to 0 and x minus 18 equal to 0. So let's go ahead and solve for x on both of them. And on the other one, at 18, and x equals 18. Now, both of these do represent the x-intercept, but in this case, the x represents seconds. Now, just like distance or time in this case can't be negative. So in this case, we're actually going to go ahead and discard this. We're not going to use that one because time in this case won't be negative. So how many seconds after launching will the rocket hit the ground? It's going to be after 18 seconds, or at 18 seconds, the rocket will hit the ground. So after being launched, it's going to take 18 seconds for the rocket to hit the ground. All right. So our answer there for our x-intercept